Today we're going to be talking about preparing for Chem Activity 13A, known as a one-step nucleophilic substitution. Up until now we've been talking about reactions at sp2 carbons, alkenes, arenes, and so on. In Chapter 12 we start talking about reactions at sp3 carbons, and particularly ones at sp3 carbons that have an electronegative group attached to them. And that electronegative group is going to leave during the reaction, taking its electrons with it. For example, down here on the bottom we have a generic sp3 carbon attached to a leaving group, and we have a nucleophile. And in nucleophilic substitution, the nucleophile comes in and binds to the carbon, kicking out the leaving group. Among other things, we're going to be looking at what makes a good leaving group, and the leaving group must be somewhat stable. In particular, we want leaving groups that are weak bases. We will be talking about what makes a good nucleophile, and a good nucleophile is one that has a pair of electrons to give away, often has a negative charge, and usually doesn't have that negative charge or pair of electrons stabilized by resonance. Now, the nucleophilic substitution can take place in one of several ways. You can imagine the leaving group left taking its electrons with it. We would get a net carbocation, and the carbocation, of course, would be very willing to react with the nucleophile to give you your substitution product. This, of course, would be a two-step reaction, with the first step, the leaving group leaving, and the second step, the nucleophile coming in. The current reaction is a one-step nucleophilic substitution. So how does our one-step nucleophilic substitution occur? We could imagine the nucleophile coming in first, and then the leaving group leaving. But this would create a very abnormal type of situation where you have a carbon that's at the center of it all that already had 4 bonds to start with, one of which was to the leaving group, and would now happen to have a new bond to the nucleophile. We know that second row elements cannot form 5 bonds, so this is definitely not the way that the reaction happens. The other possibility is that the nucleophile comes in at the same time as the leaving group is leaving. And that would in fact give us a one-step reaction. Nucleophile comes in, leaving group leaves, one step, and this describes the SN2 reaction. The reaction, the one-step substitution from Chem Activity 13A. However, it's a so-called bimolecular reaction. That is, both the nucleophile and the substrate, the alkyl halide, react at the same time, so that the rate is a function of both the nucleophile and the substrate. To actually visualize how this reaction occurs, feel free to go to the Tree Frog site. The link to this site is also in our Blackboard web links, and look for the SN2 reaction. Now, this reaction is called SN2. Let's dissect that name, SN2. The S stands for substitution. That makes sense. There's a net substitution reaction happening. The N stands for nucleophile. That is, the nucleophile is involved in the substitution happening. And finally, the 2 is to indicate that the reaction is bimolecular. That is, the rate is proportional to both the concentration of the nucleophile and the concentration of the substrate. In Chapter 12, and starting in Chem Activity 13A, we will be looking at things that are appropriate nucleophiles, good leaving group, and good substrates that allow this reaction to happen.